everyone. Welcome to our pre-calculus lesson 3. This is about finding intercepts from equations and understanding symmetry from graph. So let's look at our agenda. First of all, we will try to discuss some practice homework review and finding intercepts from an equation, understanding symmetry, then some practice problem as usual. So this is about our previous lesson. This we said that like from 1.2, 17, 13, 17, 27, 20 and 28, if you have problems in this maths, you can just tell, we will discuss it during the class. And then one challenge problem like 16 y square equals to 120x minus 2 to 5. The question is, how many x-intercepts does this graph of this equation have, how many y-intercepts have, and how do we know? So we can graph this. If you are interested, you can graph it and you can see how many x-intercepts and y-intercepts this equation gives. We can actually graph it and we can have a look at that. But that's one way. And without graphing also, we know how to find x and y-intercepts from given equation. Yeah. And the technique is actually another big part of today's lesson as well. So one thing is by graphing, by plotting points. When you graph it, then you see the shape of the graph and you see the graph is here, here and here. Then from the graph you will understand, oh, I can see, suppose, let me show. Suppose if you see that your graph is, suppose your graph is like this, then you will say, okay, my x-intercept is here and here, x-intercept is here, y-intercept is here. And if you see your graph is, let's say, suppose like this, then you can say your y-intercept is this, x-intercept is this and this. Of course, the value will be given, the points will be given. Then you see, suppose your graph is something like this, then you can say, okay, my x-intercept is here. Suppose if it is 2, 0, then you can say, just write 2. Let's just write 2. Suppose this is x value 2, then you can say my x-intercept is at 2. But there is no y-intercept in this graph, which is possible. Okay, so when you draw the graph, actually you can understand how to find out x and y-intercepts from the graph, obtained graph. And this is possible that sometimes some graphs may have one intercept, 2 intercepts, and 3 intercepts. It is possible. Okay, different intercepts is possible. It depends on the graph, shape of the graph, given function, etc., given equation, etc. Now without plotting also, we can find out the x and y intercepts from here, and that is, let's look at how can we find it out from our lesson. So to find out x-intercepts and y-intercepts, our technique is this. First of all, to find out our, we have to find out where is, for x-intercept, we have to find out where our graph is intersecting at x-axis, which means, you know, at x-axis, all the y value is 0 at x-axis. All the y value is 0. Suppose this value is 1, this value is 2, suppose. So what is the coordinate of this one, of this point? The coordinate of this point is 1, 0. What is the coordinate of this point? This is 2, 0. Which means that you can look and see the second value is always 0 on this line. Even if you come here, suppose this point is minus 2, then the coordinate of this point is minus 2, 0. And you can see the second value is 0. Second value is 0, which means y value is 0. That means this actually gives us an interesting idea, and that idea is, if we put y value 0 in any given equation, we will get x-intercept. So that's why it is written y value of any x-intercept is 0. Y value is 0. So that means if you put 0 here instead of y, to find out the x-intercept from this equation, if you put 0 here, then find out the value of x. So how can we find out the value of x? Then it will be twice x equals to minus 5. Then x equals to, you divide both sides by 2, then x equals to minus 2.5. That means minus 2.5, x equals to minus 2.5 is the x-intercept of this given equation. So how do we find out the y-intercept? To find out the now opposite in the y line, if you look in the y line, this, suppose this is 1, this is 2, the y value, this is 3. What is the coordinate of this point? If you look, what is the x value of this point? What is the x value of this point? What is the x value of this point? These are y value, 1, 2, 3. These are y value because it is on the y axis. So these are y value. X value on this line is 0. X value on this line is 0. So coordinate of this point is 0, 1, 0, 2, 0, 3, etc. And this side is minus, so it will be 0, minus 2, 0, suppose this point is 5. Suppose this point is minus 5. So it will be 0, minus 5. 0, minus 5. So you can see that on the y line, our x value is 0. That's why to find out the y-intercept, we will put x equals to 0. So what is the y-intercept from this given equation? So we have to put x equals to 0. If we put x equals to 0, our y equals to 5. Y equals to 5. So this is how we know that this is the y-intercept. This is y-intercept. This is y-intercept, and this is our x-intercept. This is our x-intercept. So this is y, this is x-intercept. So this is how we know which one is our x-intercept, which one is y-intercept from the given equation. Now let's look at, let's go back and see our previous slide. So this one also, now to find out the x-intercept, you will put y equal to 0 and do the calculation for the x. And to find out the y-intercept, you have to put x equals to 0 and find out y equals to what. Then you will have the y-intercept and x-intercepts both. You give a try. If you face problem, you can tell me. The answer of this question is there will be only one x-intercept of this question. There will be only one x-intercept and there will be no y-intercept. You do the calculation. If you get the same thing that I said, then you are right. I can tell you the value also. Okay, let me tell you the approximate value. Your x-intercept will be between 1 and 2. I will not tell the exact value. You give a try, and if you get the answer, then you are right. And there will be no y-intercept, okay, from this equation. And try to do this practice. This is also practice problem. We'll try to do in the. You can try to solve it, or we can do that these maths actually during the class time. So both is possible. Now let's try to look at the symmetry. What is symmetry? So to give you some basic idea, just very rudimentary idea about the symmetry is, symmetry means somewhat similarity. Okay, if you look at most of the thing around you, you will see that there is some symmetry. Everywhere there is some symmetry. People make things which are symmetrical. Everything, most of the time, everything are symmetrical, because I'm looking at things around me now, and I can see tons and tons of things. All are symmetric. People are intelligent. That's why they make everything symmetric. They know that. That thing. So what is symmetry? Let me tell you that. Symmetry means the figure has to be similar from some particular axis or particular point of view. Let's look at my mouse. So this is my mouse. See. You will see that this graph is also, the mouse is also symmetric. First of all, let me give you from myself. Then I will go to the mouse. If I draw a line, y-axis, just along my body at the middle, you will see that my one hand is this side, another hand is this side. One hand is here, another hand is here. So that means about this line to the middle of my body, one side is I have one hand, another side I have another hand. So you see, I have one eye this side, I have another eye this side. One ear, another ear. Okay, that means both side of the line is same thing I have. Yeah. In my configuration, the thing is made such a way so that both side of that line is same thing. This is just like a mirror. Yeah, this line is just like a mirror, and everything is same. If you just fold it, you may get the same thing at the both side. So that means my body, and if I consider this is my y-axis, since this is vertical y-axis, so I can say that technically I can say that my body is symmetric about the y-axis, because this side of the y and that side of the y is also same. And now if you look at the mouse, you will see that this mouse is also, see, if you draw a line, you will see this side and that side we have the same thing. And even this written word also written such a way so that it just goes through the middle. It just goes through the middle. Everything, actually everything, whenever they make something, they make that thing in such a way so that the figure is symmetric, because when it is symmetric, that figure is beautiful. Without the symmetry, the figure looks odd. The figure looks odd without the symmetry. If you look at the drawing of most of the drawing of Leonardo da Vinci or any other very big and famous painter, or their work, sculpture, etc., their work, you will see that their figure is also symmetric. Their figure is also symmetric. Let me show you. That one figure. Just this thing came to my mind right now, and I can show you. There is a man picture from Leonardo da Vinci. There is a picture of man. Leonardo da Vinci, standing man. So you will see that his figure is symmetric. This is one of the most very famous figures. See, this is one of the very famous figure from the Leonardo da Vinci. You will know that. See, the figure, he first of all, there is some geometry in the process of drawing the figure. He is a very sharp, very sharp artist, and in the process of drawing the figure, sketching this figure or drawing this figure, he actually, if you draw a line through the middle, you will see that the figure is actually, he tried to draw the figure such a way so that this side and that side is same. You can fold them, and you will see that this is actually, see, this leg, or this hand, they're actually same. You can fold it, right side and left side. If right side and left side is same, this is called Y-symmetry. And in some cases, you will see, of course, there are many cases where some figures, of course, all the figures are not always symmetric to everything where we will go, but just to give you an idea that this figure has symmetry, and these are the work of some greatest artist of our time, of not our time, of course, from entire human being, we can say. Okay, so they actually studied mathematics. That is another point. He was a very good mathematician, also architect, mathematicians. He used to know a lot of things, Leonardo da Vinci. So coming back to the point, my point is the thing that I tried to show you there is this symmetry exists in many places, and they are real in our practical life. Also, we have them. Now there are three types of symmetry: X symmetry, Y symmetry, and origin symmetry. X, Y, and origin. X means X-axis symmetry. Y means Y. The thing that I'm saying. Y means Y-axis symmetry, and origin means origin-axis symmetry. Origin symmetry. Or symmetry with respect to origin. Okay. I have for Y symmetry, I have done some figure also here, just to give you some idea. Let me stop share so that you can see the figure a little bit big. So you see, to find out the X symmetry, to find out the x-symmetry. Let me show this. So you see this is transparent so that you can see the both side. If you look at this is the x-axis, this is my x-axis, and the y-axis is up there. So this figure is, I am saying this figure is x-symmetric, because if you consider a mirror here on the x line, this side and this side is just like a mirror up and down. You can consider that maybe there is a mirror here, there is a mirror here, and then upside and downside of the figure is same. And how do we know that? See, the main purpose of this is folding. If you fold it, then you will see that the both side of the figure will fold. See, the thing is above one another. See, see this side. See, now the both of the figure is actually one above one on another one, right? And I have done the folding about the x-axis. That's why it is x-symmetry. Now see what I mean by that. If I fold it about the y-axis, this is my y-axis. Let me put it this way. So this is my y-axis. If I fold it, see, the figure will not be same. Figure will not be same about the y-axis. See, the both side is as it is. So there is no superposition or superposition on one another. Okay. So you see once again, this is the x-axis. So if I fold it, the upside and downside of the figure is one above another, one on another. So that means this figure is x-symmetric. And for y-symmetry, similarly, if you fold the figure for y-symmetry, this is our y-line. Y-line is up there. So for y-symmetry, you can fold the figure about the y-line. Then your figure will be same. You can fold the figure about the y-line. See, there was two figure. Now it looks like one. Just same. So you can fold the figure about the y-line. So then it is y-symmetry. You can imagine it. Suppose some math is given, then what you can do? If some math is given, you can imagine it. Okay, how can I fold it? If I fold it, does it look the same? You have to fold it about the x-axis or y-axis. If you fold it, suppose this figure is, I have folded about the y-axis. The folding is at y-axis. The figure is same. The figure falls one above another or one on another, or there is some superposition of the figures. Okay, so we can say that this figure is y-symmetric. And for x-symmetry, you will fold the figure about the x-axis and they will superpose. And for origin symmetry, you can instead of folding, you just can look at the figure. The corner and the corner will be, the figure of the corner will be same. This corner and this corner will be same. And if there is some another thing in this corner, they has to be the same in the another corner. Okay. I do not know. They used to make very nice sound. Why they are not making the sound now? Let me see. Oh my god. I have carried. That's why the air is now going out. Oh, that's not good. So let me share once again. Let me go back. So you see now, if you fold this line about the x-axis, you see upside and down is same. So it is x-symmetry. So up and down same means x-symmetry. Left and right same means y-symmetry. Corner and corner same means y-symmetry. Up and down same means x-symmetry, because the x-symmetry is in the middle. X-line is in the middle. Then in the left side and in the right side, they are same. That means it is y-symmetry. And you have to think, they must be exactly same. If you fold them, they must just directly fall one on another. Okay. And then corner has to be same, then it is y-symmetry. And the value also has to match. Suppose this point is 2, 2, suppose, then it will be -2, -2. Suppose this point is 3, 2, then this point will be -3, -2. Both of them changes the sign for the origin symmetry. For the y-symmetry, x value changes the sign. What does it mean? Suppose this value is 5, suppose 5, 4, then if it is y symmetry, the another point will be minus 5 comma 4. X value will be just sign change. Yeah. If it is positive, it will become negative. Only x value for the y symmetry. And for the x symmetry, y value will change the sign. Yeah. Suppose this value is 3 comma 2, so it will be 3 comma minus 2. Exact same value, but just y value will be negative to get the x symmetry. So there are a couple of ways actually to understand if there is a symmetry, whether it is x symmetry, y symmetry, or origin symmetry. These are some practical examples. Look at this figure. What type of symmetry do we have here? You can try to tell, then we will discuss it. You can just imagine some line through the middle or through this part. You can imagine some line, or you can draw a line here, then see what type of symmetry these objects they have, and think about it. Okay, these are things from our real life. Think about it, what type of symmetry they may have. Okay, and yeah, these are in terms of value. These are practice problem, and there are a lot of practice problem from the, these are from the figure. Okay, they are from the graphs and given figure from the book. So you will try to find out what type of symmetry they have and try to match your answer with the book. We can also discuss during the class. You can say, sir, I do not understand 40 number or 41 number. During the class time I will discuss them. These are our practice work. You can practice these works. These are from finding intercept. These are from finding symmetry, and there is a slightly optional challenge problem from our 84 number B. 84A number is 84A and B, so we have two maths there. So try to solve them. If you face problems during the class time, please ask me. We'll try to elaborate them a bit more. Okay, and all the maths are of course related to our two topics. One is X-intercept, Y-intercepts, how to find them, and another one is symmetry. Okay, how to find the symmetry. And we have one more class from the symmetry, so we will discuss the symmetry a little bit more. For example, how to find out symmetry from our given equation. We will discuss it in our coming classes. So till then, thank you all. Thank you very much and have a good day. See you all in the class. Bye-bye.